In the name of God, Fundamental of Thermodynamics. Chapter 3, Properties of a Pure Substance, from Borgnakke&Sontag, 7th edition. First we have an introduction. In the previous chapter, we considered three familiar properties of a substance: a specific volume, pressure, and temperature. We now turn our attention to pure substances and consider some of the phases in which a pure substance may exist, the number of independent properties a pure substance may have, and method of presenting thermodynamic properties. So we have the topics in which the main topics or description in this chapter: a pure substance, may exist, the second one is the number of independent properties and pure substances may have, the number of independent properties a pure substance may have. And the number of independent second, the methods of presenting thermodynamics properties. Properties and the behavior of substance are very important for our study of device and thermodynamic systems. The steam power plant and the nuclear propulsion system have very similar process, using water as the working substance. Water vapor is made boiling at high pressure in the steam generator, followed by the expansion in the turbine to a lower pressure, cooling in the condenser, and return to the boiler by a pump that raises the pressure. We must know the properties of water properly. Size equipment such as the burner or heat exchanger, turbine and pumps for the desired transfer of energy, and the flow of water. As the water is transferred from liquid to vapor, specific volume, we need know temperature for given pressure, and we must know the density or specific volume so that the piping can be properly dimensioned for the flow. If the pipes are too small, for example, the expansion creates excessive velocity, leading to pressure losses and increased friction, and thus demanding the large pump and reducing the turbine's work output. Where in the steam power plant example, there are various examples. For example, for the refrigerator, Only the substance that will boil from liquid to vapor at a low temperature, about -20, absorbs energy from the cold space, keeping it cold inside the black grill in the bag or at the pump. The now hot substance is cooled by air flowing around the grill, so it is condensed from the vapor to liquid at a temperature slightly higher than room temperature. When such a system is designed, we need to know the pressure at which these processes take place and the amount of energy. Another example of a system where we need to know the properties of substance is, for example, a gas turbine and a variation, therefore, namely the jet engine. In this system, the working substance is gas and no phase change takes place. The combustion process burns fuel and air, freeing a large amount of energy, which heats the gas so that it expands. We need to know how hot the gas gets and how large the expansion is so that we can analyze the expansion process in the turbine and the exit nozzle of the jet engine. These are just a few examples of complete thermodynamic system where a substance goes through several processes involving change of its thermodynamic states and therefore its properties. As your studies progress, many other examples will be used to illustrate the general subject. The next section is the definition of the pure substance in the next video part.